Welcome to the lecture on option valuation. So, in this lecture we are going to talk about the methods which are used for the valuation of the options. Before that we must know what are the determinants of the option value, on what are the factors, those factors on which these option value are basically depending upon. And basically there are 5 major factors which determine the market value of an option, and they are price of the underlying stock, so that is market price, then MP, so that is known as MP, then you have a strike price of the call option, that is SP, length of the maturity time that we normally denote by T, risk free rate that we normally denote by RF, and also variance in the market price of the underlying stock, so that is known as sigma MP, that is square. Sigma square will be variance for the market price. So, basically what happens that the call value, that is value of a call option, so that is we denote it as VC, so that will be value of the call option. Now, this will be this will be a factor of the, we discussed that this will be a factor of market price, then it will be the factor of strike price, then it will be talking about depending upon the maturity time. Similarly, this is a risk free return, so we normally denote it as RF, and then the variance of the market price. So, it depends upon these 5 factors. Now, if you look at if it is analyzed, then it is found that so some of the factors have the positive value. So, if there is positive increase in the these factors, then that will be, there will be positive increase in the in this call value also, value of the call option. So, some of the factors like the market price. So, if the market price is more, in that case the value of the call option will be more. So, basically dou of VC upon dou of MP. So, since market price being larger and larger, so if it will be larger, the value of the call option will be more, so it will be more than 0. So, slope will be basically 0. Then about the strike price, that when there is strike price will be larger, then in the case of call option, strike price being larger, so the value of the call will be basically decreasing. So, what happens that dou of VC upon dou of SP, this will be basically less than 0. Then depending upon the maturity time, if it is higher, then it has a positive effect. So, dou of VC upon dou of T will be more than 0. Similarly, dou of VC upon dou of RF will be more than 0, and also depending upon the variance. So, if the variance is larger, so in that case also your call value will be basically more. So, it has a positive effect on this. So, dou of VC upon dou of sigma square MP, this will be also be greater than 0. So, these factors basically affect like this. So, what is it's written that in the call option, all the factors except the strike price has a positive effect, so that's what it is. Then in the case of the other things, like if you go for the put option. Now, in the case of put option, again put option will be also depending upon all these factors. So, in that case what you see is, again we can write that the value of the put that will be again a function of MP, then SP, then T, RF, and again sigma MP square. Now in this case when you are going to talk about the put option, in those cases the MP, if the MP will be higher, in that case the VP will be it has a negative effect. So dou of VP upon dou of MP, so this will be less than 0. And similarly when the risk free rate of return, risk free return, that is it has also a negative effect. So dou of VP upon dou of RF, so that also has a negative effect. Apart from that all the other three factors like strike price, then you have maturity time, and also the variance of the market price, all have the positive effect. So dou of VP upon dou of SP will be more than 0, unlike to that of the value in the call option. And similarly dou of VP upon dou of T will be more than 0, and dou of VP upon dou of sigma square MP, it will be also more than 0. So this way these factors are changing, they have the different effects on the call or put valuation with respect to their own changes. Now we will talk about the valuation of these call and put by some different methods. So that is also clear from this expression, that except for the market price and the risk free rate, all the factors have a positive effect, because you see that the rate of change of the value of the put will be changing, and that has positive effect like strike price, maturity time, and the variance of the market price. And for the market with respect to market price and the risk free rate of return, it has a negative effect. So that is how it is affecting. Now the revolution came, I mean there was a very important finding by the Black and Scholes. So F. Black and M. Scholes, they have derived a model for the option valuation, and in that the call option value is determined by using the market price of the underlying stock, again MP, strike price of the call, that is SP, the risk free rate again that we know, the length of maturity time, and the cumulative normal probability density function. So in this case they have talked about another function, that is cumulative normal probability density function, that is. So in that case we are talking about the call option value VC, and it will be standing for the probability that a normally distributed random variable will be less than or equal to the area D, that is D is that function. So according to that, if you talk about these option valuation by Black and Scholes, so that will be by Black and Scholes. So they have basically given the relationship like VC, so call value, that will be equal to MP into multiplied by, it will be ND1, and that will be minus e raised to the power minus R into T, and then into SP, that is strike price, multiplied by ND2. So here we know that MP is the market price, and here in this case we know that SP is the strike price, and R is the risk free rate. T is the length of maturity time. And now in this case the ND, basically this is the new thing which has been given by Scholes. So that will be talking about the cumulative probability density function. So this is normal probability density function. So cumulative normal probability density function. So now that is what it is defined, that this Vc in this case will be standing for the probability that a normal distributed random variable will be less than or equal to the area D. So D is calculated basically D1 and D2, and that will be seen from a table, and that value is used for finding the Vc. Now what we do for that, we first find D1. So we have D1 and D2. So D1 is found as ln of MP by SP and plus T into R plus sigma square by 2. So and divided by sigma root T. So this is the equation for D1. And similarly we find D2, and D2 is calculated as once you calculate D1 you can find D1 minus sigma root T. So we know that the sigma is the standard deviation. So this sigma is standard deviation per period of the continuously compounded rate of return on stock. So what you do, that once you know these, you need to know you will be knowing the market price, the strike price, the maturity time, the risk free rate, and the this variance. So once you know that, you can find the D1 value, and once you know the D1, and then you will also find the D2, and once you know that, then in that case you can find the valuation calculation in such cases. This is for the call option. You can also go for the the put option. So if you go for the put option, now in that case if you find the Vp, so Vp will be Vc plus Cv into Sp. So this is current value of the strike price, so that will be and minus Mp. So that is your Vp. So Vp can further be for finding the current value, you will have to for continuous compounding you have to multiply with the factor. So it will be Vc plus you will find the Sp into e raised to the power minus Rt. That will be giving you, because it is continuous compounding, so you are multiplying with e raised to the power minus Rt, and that is again, and from that you will find you will subtract the market price. So this way you are able to calculate the value of the put in that case. Also these methods were simplified further, because it looks somewhat complex. So since they are looking at, but they can be simplified, and the simplified way is to calculate this Vc as the MP into PSP value. So this PSP value is nothing but the percentage of the share price value. Now in this case basically you have to calculate these D1 and D2, and then from the table you have to find the PSP value. So once you get the PSP value, you can multiply with the MP and you can get it. Now how can you get these values? So for that first of all you will be referring to a table, and from that table you have a vertical column and you have a horizontal column, horizontal row. So, you have vertical value and you have horizontal value, and in that once you get these two values, then you can get the values like the vertical value. So, how to refer? So, for the vertical value, for that you are going to have the product of standard deviation, that is sigma, and root t. So, that is a square root of the maturity time. So, that will be calculated, and then second is the horizontal value, and horizontal value will be calculated by dividing the market price to the current value of. So, that will be of the strike price. So, this will be market price divided by current value of strike price. Using risk free rate. So, the risk free rate is taken, and using that basically you have to find the the current price. So, you will be dividing it with something like that factor, and in that case you are getting, and for the for that the actual maturity time it will be calculated. So, this will be MP divided by CV into SP, CV of SP. So, current value of the strike price. Now, this will be MP upon SP by 1 plus RF. So, this is for the maturity time of T. So, this is done for the whole maturity time span, and for that time span when you have to calculate the current value of that strike price for that maturity time taken as the basis, in that case you have to divide it with 1 plus r raised to the power t. So, that is how you calculate the present value from any future value. You have to divide it with 1 plus interest rate raised to the power the periods. So, here you have the maturity time. So, this way you calculate these horizontal and vertical values, and from the horizontal and vertical values you can calculate these PSP value from the table itself. So, that is how you try to calculate these values from the table. You can see that suppose if you have an example, say that you have to calculate the value of the call option, and you have strike price is given as 90 and maturity is 9 months. So, and also the current stock price, so that is given as $108.50 and risk free rate is 5%. Also the standard deviation of rate of return on stock, so that is also given as 0.75. So, if suppose such are the data which are given to you and you have to find the valuation of the call, in that case what you do is first of all you have, as we know that you have two values, horizontal as well as vertical values. Now, vertical value is you will see that will be sigma root t. So, sigma is 0.65. So, sigma is 0.75, and then you will take the square root of the maturity time, that is in years. So, it will be again 0.75. So, this will be coming out to be 0.65. Now, once you, so this is the vertical value which is calculated. Now, you have to calculate the horizontal value. Now, horizontal value will be MP by so current value of SP. So, horizontal value will be MP by SP into 1 plus RF raised to the power t. So, you know that the market price, so that is given as 108.50, and strike price is shown as 90, and this will be 1 plus 0.05, and T is given as 0.75 years. So if you take that, it will be $1.25. Now you will be given a table, and from that table, basically with the vertical score of 0.65 and the horizontal score of 1.25, you have to find the percentage share price, that is PSP. Now that can be referred from a such table. This table is by the from the book McGraw-Hill. So here this table is given as sigma root 2 is in the vertical side, and your MP by CV is given as this. So you have sigma root 2 coming as 0.65, but the MP by CV is coming as 1.25. So you have to go to next table for 1.25 and for 0.65. This is coming out to be 32.6. So this is 34.2. So 34.2 is the value. So this 34.2 will be, so you have to go for the VC calculation. It will be MP into percentage share price. So percentage share price, so MP is 108.40 and percentage share price will be 0.342. So 34.2 was the value, which was for the value of sigma root 2 as T as 0.65 and the horizontal value as 1.25. So for that basically you can get this value as PSP as 0.342. So you multiply that with and you are going to get $37.11. So this is your calculation of the valuation of the call option with this method. You can even calculate this for a put option. Suppose if you have to find the put option for this example, then in that case you have the call value. So that if you have to calculate the value of the put, so that value of the put becomes VC plus CV into SP, and then it will be subtracted with the MP. So that's how you calculate the value of the put. Now in this case what happens is, so this will be current value of the strike price. So it will be strike price divided by 1 plus RF raised to the power T. So this will be becoming, so strike price is about 90. So 90 will be divided by 1 plus 0.05 raised to the power 0.75. So it will be coming to 86.77. So you can find the value of the put, and that will be the value of the call, that has come to 37.11 plus 86.77, and then you will be differencing, taking the subtract this market price, that is 108.50. So this is coming out to be $15.38. So this way you can calculate the value of the put as well as the value of the call using such methods. Now many a times you have to combine. So basically one of the best way to protect your assets against the business risk is also the method of hedging. So in that case what you do is you are combining these options and creating a mix of the possibilities, and so you have different so and then in combined way you are finding the intrinsic values. So basically we are doing this combining of the intrinsic value of the options, and in that basically we have already studied that you have two ways, one is straddle, another is butterfly. So suppose what we do basically, we are having the individual values calculated, and then we are basically calculating the final value of the call or intrinsic value of the call or intrinsic value of the put. So coming to the example of something we are taking for the straddle. Say suppose if you have an example, suppose you have to find the intrinsic value of the combined options. So to find intrinsic value of combined option, so you have two options, I mean a combination of the option which is buying a call, so that at strike price of suppose $55, and and buying a put at same strike price when market price of the stock is $68. So you have to find the value of so you have to find value when stock price goes down to $50. Now suppose so you have the combined option, you have the call and option, and it's done at the same strike price. That's an example of straddle. And how you calculate the value of this call in this case. So value of combined intrinsic value, how you call. So basically if you try to find the combined intrinsic value, so it will be basically the intrinsic value of the call and intrinsic value of the put. So both of these are to be added. So this will be intrinsic value of call plus intrinsic value of put. So in this case you have intrinsic value of call, it will be denoted by IVC, and then you have intrinsic value of put, so IVP, that is. Now this is buying basically, so that's why you have B as the subscript which is written here. Now if you try to calculate this, so intrinsic value, as we can recall, it will be, so if you, this is 1 and this is 2. Now 1 is basically, so it will be maximum of MP minus SP and 0, so that will be and plus maximum of SP minus MP and 0. So this will be your intrinsic value of the call for the buy, and if you take that, so it will be maximum of 68. So MP is your market price is 68, so it will be 68 minus strike price is 55, and then it will be 0, and similarly maximum of strike price is 55 and minus 68 and 0. So it will be 13 and it will be 0. So that will be $13. So that is your intrinsic value of the call, and intrinsic value of the put, if you look at, so this will be calculated as the maximum value of so in this case the stock price has gone down to 50. In that case now it will be 50 minus 55 and 0 plus maximum of 55 minus 50 and 0. So, this will be so if you take maximum of -5 and 0, so it will be 0, and if you take the next value, it will be 5 plus and 0, out of that maximum will be 5. So, you have 5. So, basically this way your the value of the intrinsic value of the call and intrinsic value of put function, so that can be calculated, and that can be added, and the value of the call can be value of the value can be calculated in such combined cases. So, this is basically when the strike price is remaining the same. In that case, this is the case when you have the case of straddle, and you can calculate the value. Similar will be the cases of calculation when you have the case of butterfly. So, in that case, as we know that you have the strike price is different, and in that case the values are so for the butterfly case you can calculate even those values. So, with the different strike prices, you will have a case of butterfly, and in that case situation may be that you have to calculate the individual values, and then you have to add them, and you can get the value of that option. So, this way you calculate the valuation in the case of the options. Thank you very much.